Specific latent heat. Here are the aims. Pause the video and have a look. If you heat a substance enough, eventually it'll change state from a solid into a liquid, then from a liquid into a gas. We can calculate the amount of heat energy that's needed or released when a substance changes state in joules by multiplying the mass of the substance in kilograms by the specific latent heat in joules per kilogram. I've showed how to write the equation using symbols and how to rearrange it using the magical triangle. Some exam boards use the letter E for heat energy rather than Q, so watch out for that. I'm using Q in this video. You'll be given this equation in your exams, so you don't need to memorise it, just select and apply. The word latent is a Greek word, which means hidden. The reason we call it latent heat is because, even though we're still putting heat into the system, the temperature of the system does not change while the substance is changing state, so it's as if the heat we're putting in is hidden. When heating a substance, the heat energy is being used to break into molecular bonds. When cooling a substance, the heat energy released is being used to make intermolecular bonds. I explain this in detail in my video called Changes of State. There'll be a link at the end of the video if you haven't watched it already, or watch it again to reinforce the concept. The specific latent heat is the amount of energy required to change the state of 1 kilogram of the substance with no change in temperature. When a change of state occurs, the energy supplied changes the internal energy but not the temperature. I explain this in detail in my video called Changes of State. There'll be a link at the end of this video. There are two slightly different versions of specific latent heat that you need to know about. The specific latent heat of fusion is when the state changes between solid and liquid. In other words, when a solid melts or when a liquid freezes. The word fusion means to come together. A way to remember this is to imagine you have ice cubes which are solid and you heat them. They'd melt and fuse together as one liquid. That's the analogy I use with my students. Use it if you want, or make up your own. The second version is the specific latent heat of vaporization. This is when the state changes between liquid and gas. In other words, when a liquid evaporates or when a gas condenses. I've created a temperature time graph to help you visualise how to use the equation for specific latent heat for some typical GCSE questions on this topic. Imagine you start with 1.5 kilograms of ice and heat it. I'm using the equation with specific latent heat of fusion to show how to calculate the amount of energy needed to melt the ice and change state from solid to liquid. Now I'm using the equation involving specific heat capacity that I introduced in a previous video to show how to calculate how much energy is needed to heat the water from 0 degrees Celsius up to 100 degrees Celsius. There's a link at the top of the screen if you haven't already watched my specific heat capacity video. Students do need to be able to tell the difference between specific latent heat and specific heat capacity. Saying them on this graph should help you to tell the difference. Now I'm using the equation involving specific latent heat of vaporization to show how to calculate the amount of energy needed to evaporate the water into steam, changing state from liquid to gas. Note that it takes much more energy to evaporate a substance than it does to melt it. Here's a table showing some typical specific latent heat values. You don't need to memorise the values, but it is important to know that different substances need different amounts of energy to make them change state. Here's some typical questions for you to try. Pause the video and have a go. And here's the answers. Pause the video and mark them. Make sure you correct any mistakes because that's how we improve. Here's some more challenging questions to try. Pause the video and have a go. And here's the answers. Pause the video and mark them. Well, I hope the video was useful and it helped you understand physics better. Subscribe to my channel if you want to learn more. Bang the bell all over the place, smash that like button, and apart from that, work hard, be nice, and bye for now.